Has everyone downloaded this? Does everybody have this? Raise your hand if you haven't downloaded this yet. Okay. It's taking a while. Okay.
But you have the link.
But you have the link. Okay.
All right, I'll get started. My name is Tony Robalik, Senior Software Engineer at Gradle. This is my colleague Ruz, Director of Customer Success at Gradle. And this is a talk on DevProd engineering, which is a new thing we're trying to coin with Gradle Enterprise. So it's going to be a lot about using our enterprise tool for making yourself more productive. So this is just at a high level, sort of the summary of the talk. What is DevProd engineering? The case for it, customer support for developers, so that's Ruz's stuff. The importance of fast feedback cycles, as I'm sure we all can agree on, and also creating a reliable tool chain. So you want to have, your build should be reliable, they shouldn't be breaking on you. If your build breaks, it's a problem, it's not something you should just be silent about. And we've all seen this slide. Okay, let's go on. You want to make a?
Yeah. So for us, we started, we were the company behind the Gradle build tool, and we're thinking, okay, so what is our kind of reason for existence here? Are we just a build tool? What are we really trying to accomplish here? And we're like, okay, well, we're here to make developers more productive. More productive developers means more happy developers and means shipping software, right? So you as the developers are shipping features faster, and your bosses get to see you being more productive and happier, and they make the business case, and you have a better life as a developer, right? So to do that, you're gonna need a lot of data, right? And so that's a lot of what we're gonna talk about today is just not just running builds, but let's look at the data behind the inefficiencies and the bottlenecks of the software manufacturing process.
And I almost forgot something as part of the introduction. I am actually Gradle's first Android engineer. So first, we've got people who are very experienced with Android builds, but I'm the first person who has like a cultural understanding of what it means to be a dev and to work on with Android Studio. So I feel your pain, and I come with that perspective in this talk. Right. So, and of course, Ruz has a lot of experience too with Android folks, Android teams. So software development is a creative process. It's an art, it's a science, it's both these things together. And that the creativity that comes with developing software, it does require some knowledge of the tool chain used to build your products, whether that's Gradle, whether it's Bazel or Buck or what have you. There's a dialogue with the tool chain. And the quality of that creative flow, that iteration that you're doing, when you're editing one line of XML or one line of your Java or Kotlin source code, you want to have very fast feedback. You want to be able to change that one line and have it just reflect on your emulator or on your device, and that requires a really strong tool chain. And to maintain the strength of that tool chain, you need data. And so that's what Gradle Enterprise is about.
And one thing I have to say on this is we see some interesting things out there, right, as far as like a big retail that we work with. The marketing team's like, hey, we really want to get this new marketing content out there, but now we have to wait for weeks because creativity is blocked by engineering, how fast we can release software, right? So you see a lot of that happening as well. So you kind of need this data to see, hey, how can we innovate more?
Yeah, if every one of your PR builds takes an hour to build, that's going to block new features, new feature development. And so for teams large and small, collaboration is key. It's not just with your team, but also with the business side, with the customer itself. And then, so I don't want to just read the slide, but yeah, code is an interpretation of a business idea. If your product manager says we need X feature, and you're like, yeah, it's a great idea, but it's going to take me weeks because my code base is 10 years old. The tooling is broken. I don't know why every build takes 5 minutes. That's going to be a problem. And so DevProd is all about finding ways to make that issue go away, to improve the quality of your flow, to make it faster and more effective.
And one thing we'll do today is we'll look at some of the tools that we've created, like build scans, that you can use for this collaboration, right? Developers get blocked on a regular basis for reliability issues. Is this build doing what it's supposed to be doing? Is this cache doing what it's supposed to be doing? I can't sweep this under the rug. I'm going to stop. And so we'll show you some of the tools that we use to share and collaborate. Or I have this strange build or test failure, right? A lot of this back and forth that used to happen to collaborate between a team to get this resolved now can be solved with some modern tools that we'll show today.
Yeah, and we really want the build to be a first-class citizen. I see a lot where teams, they have one guy on the team or one gal on the team who's really passionate about their Gradle build or what have you, and they're spending their weekends, they're spending their evenings working on this because they can't get their manager to give them the time during a normal, cycle to do it, and that's a problem. You need to really focus on this stuff because if you can save 10 seconds per build across a team of 10 developers, that really adds up fast across a week, across a month, across a year. So it's important to take this stuff seriously and not just do it as a weekend hobby project. Yeah, and of course, as you know, the build is very complex, particularly in Android. Ruz likes to say that for an Android team of 10 developers, it's as complex as a Java team of 100 developers. Because Android is a complex environment, and it's very challenging to do it right and to do it well. I think we've said all this stuff before. So you want to elaborate on any of this?
Anything we missed here that we already talked about? Faster feedback cycles, reliability, yeah.
Yeah. All right, so one of the main assumptions here is that it's a seller's market for your labor. If you're unhappy, it's easy to go somewhere else, relatively speaking, particularly if you're a mobile dev. And so it's very important to have a happy work environment. We want to build happiness here at Gradle and in Android. So it's important from a business side to have everyone having a good work environment.
Yeah. And when I see this slide, I recall a conversation that I had with the head of tooling at LinkedIn who runs tooling for YouTube now. And he's like, hey, if we don't provide the best tools and the best experience for our developers, they're going to leave. So for him, it was the first time that I had thought of it that way was that, okay, it's like we have to provide the best tools or there's folks worried about developers losing talent because of lack of tooling.
Yeah.
Right.
And of course, we're Android developers, so we like Kotlins. We're always on the cutting edge of stuff. We're always using the newest and best, and if we're not, we're unhappy, we're bored, we want to move on to somewhere that will let us experiment with the newest things. All right. Okay, so the primary tool for this is build scans. You want to talk about that, Ruz?
Yeah. So some of the stuff we're going to show today is Gradle Enterprise, stuff that you have to buy, but there's stuff that's a free services that you can use as well. So it's up to you to see like, okay, how do I use my tools that I have to accomplish these things? We're not saying everybody has to be a Gradle Enterprise customer, but that's how we're going to show how we do some of it. So it's up to you to kind of apply that to the tools that you guys would use in your daily lives.
Should I give them a tour of the build scan or something?
We're probably going to, we should just do that in the first lab.
Sure.
Okay, so, yeah, so what we do, right, to gather some of this data is...
This is how we make money as a company.
Right, yeah. And we collect data from every build, right? So we look at every local build, every CI build, and we capture that data, we run aggregate reports on it, and many large-scale organizations do that, right? Like Google this is like one of their, bread and butter. They have 650 developers working on a productivity engineering team. They collect data from every single build. Every developer works on an IDE, and their dev prod team, when an intern joins, they know because they see, hey, is work being done? Is code being built, right? So they look at a lot of this stuff, right? And even like the folks like companies that don't use Gradle Enterprise, they have their own way of collecting a lot of this data by putting hooks into the build system and sending that data back and running aggregate reports on it. So a lot of the things that we'll show, that's kind of what it does.
Okay, so as part of the workshops we'll be doing, there's 5 interactive labs we'll be going through. This URL is publicly accessible if you have the right username and password, so please go to that link and type in the username and the password, and then I'll give you guys a minute to do that, and we'll move on.
Has everybody signed in the sign-up sheet? Can I have my laptop back?
No, you can't, Ruse. If you're having a hard time reading it, it's just enterprise-training.gradle.com/scans. Username is attendee, password is Gradle. And once you're there, it'll look like this. You will see, this is from a workshop we did a couple of days ago. You will see all these scans from your colleagues in the room getting published in real time. Actually, let me just clear that.
You want to go back to that? Yeah. So basically, what you guys will see is all the labs that we're going to do, just like the previous screen, the slide that we showed, we're going to capture the data from every single lab. And so you can go and run a query on, hey, show me all the labs that I did, all the builds that I did during this workshop. And we're going to visualize it, and we're going to have some fun with it, and we're going to look at the data and see whose build is faster and all this stuff. It should be fun.
Yep. Who was the newest computer?
Yeah, exactly. Who's building on Windows? We'll know.
Raise your hand if you're still working on this part. So I got at least one. Okay. It's enterprise-training.gradle.com. What's next? Okay. Is anyone in the room using Maven? Are we all Android devs here? If you're not an Android dev, raise your hand. So, you. So, are you guys Java devs? Do you use Gradle to build, or? Okay. Okay. All the labs are in Gradle and Maven, that's why I asked, so I want to know if I should focus only on Gradle or if I should mix them up, but I think I'll just do Gradle for this workshop. Cool. And if you missed the first link several slides ago in the beginning, it's here again. This has all the lab materials. And I think I'm just going to get going. Okay, so now's the time. So what was that?
Well, I can
repeat the question.
So the question is, how does build scans compare to Jenkins? Okay, so let me ask this. Who of you knows what a build scan is? Raise your hand. Okay, wait, sorry. Who doesn't know what a build scan is? Who has never created a build scan? Okay, good. So it's gonna be great first lab then. So your question is, so we're complementary to Jenkins, right? So we take all the data from a Jenkins or a CI or a Team City or a Circle CI or whatever build, and we produce a nice UI around it. That's what a build scan is, and we're gonna do one in the first lab.
And so this is the interactive part of the program, so please go and the zip you downloaded, if you haven't already expand it, go to this directory and just read the read the README and follow the instructions. And I'm gonna walk around the room, and see if anyone has any questions, just raise your hand and call out to me. Thanks.
Yeah, so the first lab, we're gonna create a build scan. So Tony, you wanna take, well, give
Well,
you.
you can all walk around too.
Yeah, you can take this side, I take this side.
We'll give it a couple minutes. One important point here is that it's best if you just use the command line for this. It's just all really small, simple projects. Don't bother opening it in IDE. And you can even edit the files with just a simple text editor like Vim or Emacs or whatever you like. Notepad is fine too. Oh, should have that. So I'll even just demo it right now for those of you who are working on it. Labs 01, Gradle. Okay. So that's just my alias. Is that visible? Is that bit visible at the back of the room? Cool. Okay. So this is what it'll look like. You get the build scan link, just command click on that. This is a build scan. Let's look at the README again. Where is it? There we go.
And is everybody good here? Is anybody stuck? Right.
Yeah. Yeah.
Okay. Do we give it a couple more minutes?
Well, I'm just going to run through the lab, and then I'll wait at that point, just for those of you who don't have computers. Okay, so what's the warning in the console output? So in the build scan, there's a lot of features here, but one we're showing off at the moment is the console log is captured. So there's the warning. Please note that as I click around here, the URL actually changes. So this makes collaborating really easy. If I have a problem in my build and I want to talk to a colleague about it, rather than having to like zip up console logs and send it to him or her, or copying and pasting stuff, I'm just like, here's the link. This is precisely what I'm looking at, and so there's no more ambiguity. And so that really helps with collaboration.
Why don't you just do it?
I just did.
Oh.
Yeah, see, click.
Great.
Okay, what version of Commons Lang is being used by the build? So another feature of build scan is showing all the dependencies. So I can just click here and look for Commons, if I can type it right, Commons Lang. So we're using 3.3.6. So pretty easy. You can even, I don't think this one has it, but yeah, we can see where it's required, where repo came from JCenter. That can be pretty powerful in various circumstances. Was the publishing plugin used, applied to the build? It's kind of a trick question. You would just go here to plugins, you would look for publishing. You don't find it, so no, it was not applied to the build. In fact, just to give you a quick like Android tip, look in your build for Fabric. If you're using Fabric, you want to then make sure you're disabling Fabric for debug builds. Otherwise, you're going to pay a price of like 30 to 60 seconds per build. Okay. What OS and JVM? Okay. Another feature, infrastructure. So now I know that this build was run on a Mac with 8 cores, use this version of the JDK. This is the max heap size, et cetera, et cetera. So again, this is we're capturing all this data, which just provides more context for you, the person interested in the build, to understand what happened during this build or why it happened. And when then was the build cache enabled. So here we can just go to switches, just one up. I see that only the daemon was on, but every other Gradle switch was turned off. So the build cache was not enabled for this build. And then, okay, has everyone done this part? Have you introduced a compile error? So that's pretty straightforward. Let's go to, it's Java, pretty simple. Take away the semicolon. Let's run the build again. Yep, got a failure as expected. And now let's see, what's the question here? Let's get the error, sure. So the error was simply just that, as we know, compilation failure. And there's a stack trace here as well. So it can be, again, very helpful just for collaboration with your teammates. Let's see. Okay, this is another scan. Let's do that. All right, so what are the questions here? How much time spent configuring the build? I know we all care about configuration time, so that's easy to find out. Go to performance, and then configuration. I can see this build spent 5 seconds configuring itself. You see also all these submetrics, how many tasks were created. So let's see. Yeah, so this build applied the Kotlin plugin, so of course it's going to eagerly realize every task in the build, because Kotlin's fun like that. Any memory pressure while running the build. So that's easy to find out as well. Under performance, then build. We see that there was no memory pressure at all. This build had 2 gigs of heap, and it only used less than 1, and total GC time was less than a second. So one thing you should be aware of is that if your GC time exceeds about 4% of your total build time, that means you need to give your build more or less memory depending on the situation. But if it's more than 4%, that's kind of a good heuristic. If it's more than 4%, you have memory issues. What else we got here? Average download speed, okay. Fetching from the remote cache. So we got the build cache section here, remote cache, there we go. So this build had a 29.1 megabytes per second download speed from the remote cache, so that's pretty fast. If it's less than a megabyte per second, you've got a networking problem to investigate. And then how long was the daemon alive? Again, so we can see that. This daemon has been alive for 2 minutes and had run 4 previous builds. As many of you probably know, the longer the daemon's alive, the more builds it has run, the more efficient it's going to be. Your first build with a cold daemon will always be slower than your 10th build with a warm daemon. Which is why we recommend using the daemon in all builds, which is by default at this point in time. All right, that was the first lab. Are there, who didn't finish the lab? Are there any questions? Yeah? So the question is, can I explain more about the daemon? When you run a build without the daemon or with a cold daemon, your build is like any other JVM project. It's just-in-time compiled. And so with the daemon enabled, a lot of things are kept in memory. So rather than doing all this file I/O during your build, it'll just cache that stuff in memory instead. So that'll obviously be a lot faster than pulling it from disk. So that's just one optimization that the daemon enables. And because it's a JVM environment, the longer it runs, the more efficient it'll get at running your code. So now the question is, sometimes the builds get really slow, and then if you kill the daemon, that seems to improve it. That suggests a memory leak. Either your build itself or a plugin you're using has a memory leak, and you can very clearly see that by running subsequent builds. So run a build, run it again and again and again. If the amount of memory being used here is going up, you've got a memory leak. And if that's the case, one thing you can do is there's a free tool called Gradle Profiler, which I highly recommend everyone downloads and installs. And you can use this to profile your build both for like CPU cycles and also memory usage. And so you just run a build with this profiler enabled, and it'll give you a flame chart basically, and you can just observe where the hot spots are in your build. And really powerful, very highly recommended to use this to treat your build like a real engineering thing and not just like this magical black box.
And that was a great question, by the way. So this is an interactive workshop, throw those at us, right? You know, a lot of times, you know, we assume, we live in Gradle land 24/7, so we assume, make certain assumptions about how much Android developers interact with the build and what they know and what they don't know. So throw it at us. Right.
Are there any more questions? Great. This is just a build scan. So this is a publicly available free feature. It's at an enterprise link because we're publishing to the enterprise instance. But if you just ran your build with --scan, it will go to the public scan server instead. Yes, yes. Everything's basically identical. The only thing you don't have is, let's see, this button right here. This navigates to earlier and subsequent builds on the same workspace. Obviously, if it's a public scan server, we don't have that facility. But if you have your own instance, you have that. But everything else is the same, basically, and a couple other little things. But all the other features are there. If you go to this link here, oh, oops, I was clicking too fast. This link here, download the zip file and extract it. It's a Gradle, gradle.es/MDPW. The question is about --scan. Yeah, if you run any Gradle build at all with, so what it would look like, Gradle W assemble debug for Android, and then --scan like that. If everyone can read that, that'll just produce a build scan, which will be on the public scan server. So it is public, but it's not discoverable. The link is, it'll look like this with that hash there. So it is public, so if your company is a little bit iffy about that, make sure to check first. But it's not; these aren't discoverable links.
And you can delete it immediately.
Yes.
So we have folks from certain organizations so that are sensitive to that stuff. I mean, if you think about it, right, some of the sensitive information could be in your dependencies, right? So if you're working on a secret, flying cars technology, and you might not want to, but you could delete it immediately right away, right? So,
Yeah. If this were a public link, there would be a minus button here to delete it immediately. No. No, we don't collect any data. Google does if you run builds through Android Studio and you've opted into it, but we don't collect any data. Any more questions? Just going to clean up my browser a little bit. Let's see, just want to, okay, I need all those. Great, close that one. Okay, moving on. All right, so build scans are extensible. There's 3 primary ways to extend them with metadata, essentially. So there's these 3 things here. We call them tags, values, and links. A tag is simply a string. I wonder if, yeah, this one has it. So for example, you'll see that this scan has 2 tags at the top of the screen, lab02 and local. We'll go more into how these are created in a minute. Another way of extending scans is adding these custom URLs, so you can easily add a URL right here. This one goes to the Gradle GitHub page. A common use case for this is to link to your CI. So you could link to the build on Jenkins, so you have this connection to the CI build, and then Jenkins, if you have the Gradle plugin installed in Jenkins, it'll link back to the build scan, so you have this circular connection. Again, it's all about providing context, so you can help diagnose issues more quickly. And then the third way is adding key value pairs, just a simple map of key value pairs. These are trivial, not interesting, but a more advanced example, I have this link here. How can we send this out? If you go to the Gradle GitHub organization, then search for Gradle build scan snippets, you'll find this stuff. And it's a whole open source repository of copy pastable snippets for extending build scans. In this example, we're adding various tags for the OS, so you can easily tag, is it Windows, is it Mac, is it Linux? We can tag what IDE it is. So I know, for example, if my build if it was run on Android Studio or not, I could add all this Git metadata. We'll go into this in more detail, but just so you see that this is all, it can get pretty advanced. As creative as you want to be, you can be creative with these build scan links.
And it's essentially to give yourself more context around your workflow, right? So one of the things that Tony showed was we tagged dirty builds, right? Hey, I just ran this build, and I ran it again on CI. I didn't change anything, and it failed. It passed on my laptop. Mm-hmm. What happened? Oh, it has a dirty tag, so there were some changes, right? So stuff to give yourself context, right? Like, hey, I want to, sometimes I run builds from my home laptop. I don't know, I'm just using it as an example. You might not do that. And I want to know, hey, this was from this ID, or this was from a Windows machine, or this was from a Linux machine, and you kind of have that context. So it depends on your workflow and what you want to do.
So what I think we'll do now is we'll do lab 2, and then I will show some other more advanced examples of why this can be useful in a real world context. So let's do lab 2 now. Just get started, and we'll pause for 5-10 minutes, and then we'll get back into it. There was a question about the relationship between the number of workers and the number of cores on your machine. If you have a project that's pretty big and you don't run in parallel mode, let me see if I can demonstrate that actually. All right. So this is a build scan from one of our customers, chess.com. They're an Android team, and they've given us permission to show this data. So this is just my disclaimer. First of all, what you're seeing here, and this visualization is what we call the timeline view. This is all the tasks that ran in the project visualized so the vertical stacking indicates parallel execution, and then the horizontal is just, that's the critical path of the build, basically. If you go down to infrastructure, you'll see that this was an 8-core machine with 8 workers by default. If you run without, and then you see as well that parallel build is turned on here, so parallel is on. By default, parallel is off, you have to opt into it. So if you haven't done that and you have, let's say you've got 10 projects, or 10 sub-projects, 10 modules you might call them in your build, they're all gonna run end-to-end. It'll just be one long line. There'll be no stacking. And so you're wasting 7 of your cores in that case. So you do wanna have That's one reason to have modularization, to have parallel execution of tasks. And then you want to have at least as many projects probably as you have cores, just to get the most use out of your CPU. But even in this case, with a team that's done a lot of work towards modularizing their app, they've got like 60 projects. In this case, 49 of them ran as part of this build. But they still have half their code in the app module. So that's why I see that long tail, right? All this stuff is happening in parallel. Like the first half of the code base is getting compiled in parallel, and the latter half's taking a significant amount of time. But to answer your question about the relationship between the worker counts and the cores is complex. It involves memory as well. The more workers in a build, the more memory your build's going to use. Put your machine under memory pressure. That can slow your build down. So in some cases, you actually want to reduce the number of workers instead of increasing them to have less memory pressure if you have like a memory-constrained environment. So it's more of an art than a science, unfortunately. It's a great question to ask in like the Gradle community Slack, because people, it's an open Slack, you can join without even needing an invite, and there's been a lot of discussion in the Android channel specifically about how to manage memory. So I would encourage you to do that as well.
Is there a link to that?
Yeah, if you just Google Gradle community Slack and go to the first link, it's a Gradle forum link, and then you would click on this link here. You could just join that Slack channel, and there's that Slack instance, and then there's a Android channel inside that with a lot of discussion of people like yourselves wondering what best practices are. I'm gonna, at this point.
I was going to show something in the build scan, actually.
Okay. Which one?
This last one.
Okay.
And so if you go to some of the things in the build scan, right, like as Tony was showing the switches, whoops. So there's little links here. So if you wanted to know more about parallel or configuration on demand, right, you click on this guy and it'll take you to the tutorial in our documentation for exactly the best practices on how to use that.
Yeah. Good point. So at this point, I'm going to go through the actual the lab, so you can see it for yourself if you haven't done it already. Delete all that. Well, everyone who hasn't done the lab or has questions about the lab? I could maybe just move on.
You want to show the Jenkins integration?
I can do that with this actually. So.
Well, how many folks here use Jenkins for their CI? Okay, pretty much everybody.
Yeah, so I did promise that I would demonstrate some advanced use cases, and I'll do that right now. So again, this is the chess build, a scan from one of their builds, and they have a number of tags up here. So for example, I know that the build was cached, meaning the build cache was turned on. So they add this tag because they noticed that some of their developers had manually disabled the cache, and they wanted to just track that, just to understand better why, and they could ask the developer, like, why did you do that? Why did you disable the cache? Maybe there's a real problem to solve, maybe there's not. Maybe it's just a matter of superstition or something. I know the build was run from CLI as opposed to Android Studio. I showed you an example of how you can figure that out up here. So it's just like a hidden project property. And again, this is a publicly available snippet you can add to your builds. I know that the build was a local build, so on a laptop as opposed to being on Jenkins. And I know that it was on the master branch. So those are tags you can add that just help add context. As far as custom values goes, actually let me find a CI build. Just to give it more. Okay, so this is a CI build for the same team. Again, now it's CI instead of local. Similarly, it's going to be CLI. They don't use Android Studio on Jenkins, of course. This link goes to Jenkins itself. Actually, I can just click on that. So now this is their actual Jenkins project. So they've got that connection, and then from here, they can go right back to the build scan. So there's a circular connection, which can really help with debugging issues. They've got a link to their source, which I won't show you. This goes to the GitHub, their GitHub, basically. And then this link is really cool. This actually goes back to their Gradle Enterprise instance, and now it's filtering the view for all builds on the same commit. So now I can see, there's only one in this case. This is only just a single build on this commit, but if I had, as Ruth pointed out earlier, if I had a local build that failed and a CI build that succeeded, for example, I could do a filter like this, and I would see more than one build here, and I could compare the two to see what the issue was. And I'll talk about build comparisons later. Another interesting example that they have is So they know the build number, they know the job name, they know that this was, let's see. There was an issue where the Jenkins had the Android SDK of, it was the same nominal version but an older revision, because they weren't running SDK update a lot, but their local devs had done that because they have SDK manager on their computers. And so because the SDKs were actually different, there were different jars, they were getting this like massive cache, like a lot of cache misses. And so now they added this to their custom values so they can track that. If they have a cache miss issue, they can see, oh, Jenkins is on 6, but I'm on 10 locally, and now I know why I'm having an issue. This is probably the cause. Just some examples of like more advanced use cases for this. Are there any questions?
In the tutorial, actually, there's a challenge saying launch it on each time it fails. Like, it shows how you do that.
Launch a, sure. I gotta find the speaker notes actually. Yeah, let's see if I can make that bigger. So in the build scan block, there's actually a, yeah, there's actually another a hook called build scan published, and then you just pass it, takes it to closure, takes a scan instance, I guess, and then for a Nix system, you just do it like this. On Windows, it'd be start, so you can see that for yourself, I think. Oh, whoops, sorry. And I don't know why it's this weird coloring, but whatever. So that's how you would do that. And this is just simply Groovy. You can take a string in Groovy, call execute on it, and it's like a command line execution.
Did I answer your question?
There's a question over here, I think. Yeah. That's a good question. Let me just go back to the scan. So in general, when a task is executing, so these are all the tasks that ran in the build. They're listed by name here and visualized here. When a task is executing in Gradle, it takes a lock on the project instance. And so because of that, it's like a mutex. No other tasks in that project or that module can run in parallel because they can't acquire the lock on the project. So in the general case, parallelization happens across modules. But there are cases where it's possible to parallelize within a module. Generally, we achieve that with what we call the worker API. So just Google Gradle worker API, and that's a way of telling Gradle that your task doesn't need the project instance, don't take a lock on it, run your tasks, all these worker tasks in parallel, and so that's another way of getting parallelization inside your Gradle build. Any other questions? Cool.
I'd like to actually visualize all the builds from Lab 2.
Oh, sure, yeah.
So the build scan service is a free service. Anybody could use it. This feature is Enterprise. This is a paid feature. And here we just do a search of all the Lab 2 builds. And we can see all the builds that you all published from Lab 2. And we had a few failures here, and we can even visualize it.
Let me make it a bit smaller.
There you go. And see, how long the builds from Lab 2 took, right? And just some cool things that you can kind of do with that.
Yeah. Yeah, so these are all the builds in the past day, so you can see that there's some failures, many successes. Thanks. All right. Should I? Oh, this would be the build comparison example. With the.
I think from a single scan going back, I think.
That might be hard to achieve. Do I have notes? Sorry, we're just collaborating together. There we go, okay. So one of the goals of dev prod engineering is you want to reduce the number of failures. You want to make your developers, you want to have their lives be happy and smooth and not be interrupted or blocked by build failures. One thing you can do with Gradle Enterprise, which is really cool, is this thing we call build comparisons. You can think of it as like a build diff, like a git diff. So in this scenario, I've got two builds on the same commit. one failed and one succeeded, indicating some level of flakiness, and I want to investigate that. I can initiate a comparison very easily. And this will show me everything about the two builds that is different. So the first thing I'll see is that there was only a single task that had different inputs. So Gradle, the Gradle model is, all these tasks, they have inputs and they have outputs. And if two builds on the same commit have different inputs, that's a problem. The class path here is different. I don't know why, that's very weird. I can go to the dependencies tab here and see that for my successful build A, I resolved version 1.5 of this dependency. My failed build B to version 1.6, and that's my smoking gun. I can reasonably infer that my build is compatible with 1.5 and not with 1.6, and pin it to 1.5 and solve my build failure problem. So yeah, this is one example of using build comparisons that's really powerful. Another one, I actually have an example for that. Let's see. Yeah, this is the one I want. So I ran this build earlier, and I want to compare this to Jenkins to look at cache misses. So I showed you this earlier. You click on this link here, and I get all the scans on the same commit. And so this is my local build. This is my name, Tony. And I want to compare it to the Jenkins build. I'm just going to switch them around because I want Jenkins to come first, and then compare it. Here we have another example of a build comparison. We see that these are the two builds on the same commit, local and remote. They should be identical, but obviously there's environmental issues happening here because there's 400 tasks with differences. And we can use this to investigate cache misses, for example. So here I see that, I don't know if you can actually see that very well in the back. Zoom in a little bit. Quick crash course in task inputs in Gradle. So this is task for Kotlin. It's a Kotlin task. It's named Inspect Classes for Multi-Module IC. And it has an input with this random generated name. It has absolute path normalization. Now when something has absolute path normalization, that means it cares about the absolute path to the input. Okay? And if you have CI and local, clearly there'll be different absolute paths. You can even see that visualized here. The Jenkins path is var, lib, Jenkins, etc. The local path for me was users, Tony, workspace. So different paths mean that, and because we care about the absolute path, as they've declared here with this normalization, they've normalized the absolute path, then these are going to have different inputs, and then that's going to break the cache. It can even break incremental builds in some cases, depending on the situation. So anyway, this gets quite complex. I'm happy to talk about it more after the workshop. Okay, let's go on. Yeah, so the other thing is that we want to not just resolve errors reactively, but actually proactively resolve them. So to show you one thing you can do with that, this is going to be the, oops, wrong one. Too many accounts. So this is actually the Gradle Enterprise instance for Gradle itself. I want to look at just Gradle. These are all the Gradle build tool builds. I can now look at all the failures. So this is all the failures in the Gradle build tool build in the past 7 days. There's been 274 of them. It's not so many. Of 107,000 builds, so we're pretty stable. But here we can see what are the actual failures in our build, which are the ones that are really impacting our developers, and can we solve them to resolve things as quickly as possible.
Can you talk about the verification versus non-verification and kind of what we do there?
Yeah, sure. So again, we differentiate the failure into two types at this point in time. Verification would be a test failure. A test failure is not very interesting. If you're iterating on a feature, and your test fails, you know why it failed probably. So by default, we show quote-unquote non-verification failures, which are going to be build failures. And so what I love about this is that too many failures in the first run. Yeah, so that's an interesting, that's like a meta failure. Another popular failure that I've seen before is simply that build was canceled. And if your top failure is that your build was canceled because your developer got bored and hit Control-C, maybe it's a problem, maybe it's maybe it's not a problem. But this is really cool for people who have build issues.
And kind of where this came about was an engineer that we work with from Tableau that now works at Gradle. They started collecting data around build failures, and they started classifying, hey, what type of build failures do we have? And they wanted to improve the productivity of their developers. They're like, how can we improve that if we don't know what kind of hell or crap they're dealing with on a weekly basis? So let's see what's going on, right? Because if you want to help your colleagues out, right, to improve the productivity and essentially ship features faster, you want to know, hey, what is blocking them on a regular basis? There's certain folks that complain and they say, hey, I have this failure. And then what Sam realized was that, hey, there was 10 other developers that also had that failure, but they just didn't say anything, right? And one developer did, and it caused for that failure fix to be prioritized, but the other 10 developers didn't say anything, and they just spent hours trying to resolve it. Now, that could be a dependency issue, it could be a flaky test, it could be a reliability issue, right? So looking at a lot of that stuff has a pretty big impact.
Yeah. So I like this chart for a couple of reasons. We have two teams, one with 11 devs and one with 6 devs. The team with 11 devs, they have a 4-minute build time. The team with 6 devs has a 1-minute build time. And the smaller team has significantly more built than the bigger team because their builds are much faster. What this is showing you, and what should be showing your managers, is that faster builds makes you more productive. Means you get those features out faster. You're not sitting around waiting, perusing Reddit or something, making Slack emojis. You're actually, doing the work, and this is why this is so important to do. So, and this is interesting. So we have a difference here. We have like a typical Android team, under 10 devs maybe. Java Enterprise team, 100 devs. If you can cut the build time even by a few seconds, over the course of a year, you're saving 44 days, over 5,000 days in the enterprise case. I mean, these seconds add up. So this is why dev prod engineering is something that we think is very important and why we're promoting it in these workshops.
And same with the failures, right? It's, some of the things that we look at is some of our data says, hey, 5% of local builds that fail require investigation, right? We've seen Android team of 10 developers do 1,000 local builds per week, right? And let's say you have 20% failures, right? That's going to be 200. 5% of that's going to be 10 failures, right? So you have to run a clean, so developers, first thing they do when they come to these failures is they run this clean build to try to reproduce this thing. So even that process to try to reproduce that failure could take 10 to 15 minutes just to reproduce it. So if you had the build scan, you at the minimum save those 10 minutes because hey, everything that happened, this is a single source of truth. And I don't need to try to reproduce it. I can kind of pin it down, right? So even that, you look at if that happens with your team of 10 or 5 developers, it happens 10 times a week, you're saving 10 minutes just from trying to reproduce this thing, that stuff really adds up, right? That's just per week.
Yeah. We all know this is very true. In fact, 5 years ago, my first time experiencing this situation was I wanted to learn more about Gradle. I was a new Android dev at that point in time. And I set out to write a Gradle plugin. Espresso was new. My team was using thread.sleep everywhere to wait for views to render. And I was sick of how long that was taking. And at the time, there was no straightforward way to disable animations in your emulator. And so I wrote a plugin to help me do that. And my greatest compliment came when my coworker said to me, Tony, since we added your plugin to the build, I no longer have time to browse Reddit anymore. Like the build took half the amount of time, and he run the tests, they're done, and then he's back to work. So that was pretty cool. Oh, I didn't know there was more. Yeah, so we've all experienced this kind of thing. Context switching sucks. It really breaks your flow. You don't want to deal with it. Yeah? Okay, don't want to belabor the point. And of course, if you're waiting on a long PR build, if it takes 10 or 20 minutes to run all those integration tests, then you have that fear starting to build. Oh my God, will someone else merge to master before me? Will there be merge conflicts? We'll have to deal with that as well. I mean, it can be really painful, so the faster the build, the better. And in fact, we've noticed that if you're using the remote cache, which is, by the way, free to use for Java projects that use Gradle, it makes CI just so much faster. Like, it really works wonders on CI. Particularly for those of you, I think, who in here uses like Circle CI or any kind of ephemeral CI systems? Yeah, so when you're doing that, that means every build is going to start up a new agent, run the build, tear it down. There's no local cache whatsoever, and so you have to rebuild everything from scratch every single time. Also run all the tests from scratch every single time. So with the remote cache, that solves those problems. Things that haven't changed don't need to re-execute, they come from the cache instead. They can easily cut your build time on CI by half.
And as you can tell, we're getting you guys excited and buttered up for the next 2 labs on local cache and remote cache.
Is that a enterprise?
No, the Gradle remote build cache, just Google that, and it's a free thing. You can just, it's like a jar or a Docker file. You can easily just run it anywhere in the world.
And everything we show here, you can do it your way. It's just we're demoing it with Gradle Enterprise, right? Of course, if you want to trial Gradle Enterprise, you certainly can.
Yeah, happy to have you pay us.
I think we should.
Yeah, let's go. Skip these slides, move on to the next lab. Yeah, merge conflicts are a problem.
Long feedback cycles, everybody knows, yeah.
Yeah. So I've touched on this, but I'll explain it in a bit more detail. Who here doesn't know how the build cache works? Everyone knows how the build cache works? That's, I guess, all I need to focus on. I mean, that's unusual. Usually people have a lot of questions. So a task is a thing. It's a piece of work that has to be done in your build. It has inputs, has outputs. If the inputs when Gradle is about to execute a task, it will hash the inputs. And then it produces the outputs. It'll hash them as well, keep it all in memory. If you then run the build again, when it goes to execute the task one more time, let's say it's like a compile Kotlin task, it will hash the inputs one more time. That hash matches, if it still exists in the cache, it's like, oh, I don't need to run this build again. I'll just pull it from in this case it'll be the memory cache, but if it's, with the remote cache involved, now it's like anywhere in the world that task ran, if it's in the remote cache, I can just pull it from the remote cache and save the execution time. So this works really well for computation-intensive tasks like compilation, not so well for file I/O intensive tasks, because the cache is very file I/O intensive. So there's no point in caching those kind of tasks. But it works really well for compilation and test execution.
And you want to talk about the difference between build cache and like an artifactory, binary?
Oh, and just as a disambiguation point, the build cache is not the same as an artifact cache. So your libraries, they're in an artifact cache. There's binaries that you download. But the build cache is really just like a fine-grained task output cache. Different things, similar names.
So we're essentially caching all the steps in your build process, right? So how many of you are aware of incremental builds and look at that? Incremental, okay, great. So essentially this next lab that we're gonna do on local cache is, so before the local cache, we had incremental builds. It's been around for a long time, and so you run this build, you make a small change, and Gradle's up-to-date checks go around and see, hey, this change that you made, what is not up to date essentially, and let's build that, right? So now local cache kind of stays there forever, and you can, with incremental builds, if you switch the branches, that cache would essentially be wiped out, but now it's not, and yeah. And so these are some of the things that we cache.
Yep. And this is the benefit we see with our own build at Gradle. So build times have gotten 80% faster once we introduced the cache. So really improves our lives. In fact, I won't show it. Too much time.
Yeah. Okay, let's do.
Okay, lab 3. Let's do it. I was asked, is the build cache enabled by default? And the answer is no. There's 2 things you have to do to enable the build cache. One is in your Gradle properties have this line here that just says to Gradle, build cache is on for this build. And then the next thing you have to do is, okay, so once you've done this, by default, the local cache will be turned on, and that's all you have to do actually. It's only when you want to enable a remote cache, you gotta add more configuration. That'll be the next lab will have that. It's org.gradle caching equals true. Is anyone still working? I think the question is, would I advise enabling the cache globally for all my Gradle projects or only on a per project basis. And I only do it on a per project basis, but then I do it for all my projects, so it begs the question. It's user preference. Just for those of you who don't know, if you have a Gradle properties file in your Gradle user home directory, which is just .gradle, Gradle.properties, that will override any settings you might have in a project Gradle properties file. So you can actually enable all kinds of things for all your local builds that maybe aren't enabled for your project. Just something you can do. And I don't know, it's possible to do it, so might as well.
But I thought that we always use Gradle rocker, which is the local Gradle, /Gradle.
I'm referring to, let's see. So I can even show you mine, I guess. No, I can't. Definitely can't. There's passwords in there. But if you, it's right here, basically. So that's where the file is. So it's in your user home directory, .gradle, Gradle.properties. And I have passwords there, so thanks. Are there any questions about that lab? Did anyone have any trouble?
You want to just run through it?
Sure. Let's see, so I already showed this. So open the Gradle properties. You see that this is how caching is turned on for Gradle. Let's build it. Okay. What were the actual instructions? Why is it all the way over here? Oh, then do it again with a clean build this time. Okay. What's that? Oh, you're right. I'm sorry.
Good catch.
Good catch. Good eyes. It's a different version of Gradle. Oh, I know the cache is not for this one. You see that I had to start a new daemon. That's because the other build I had the cache turned off. Now this one's turned on, so it's incompatible. So let's do it again with the clean build this time. Thanks. That's fine. And as you can see, the first build took 18 seconds. The second build took much less than a second. And 3 things came from the cache. And so what?
Click on the first build scan, actually. The non-cache.
Okay, sure. Yeah. You know it better than I do. What are the instructions? Okay, confirm compilation and tests were executed. Okay. Yeah, so this is the timeline view as I've discussed before. We can see that compile Java, that had to be executed. It was not in the cache. It was a miss, both local and remote. And then also compile test Java had to be executed, and then the test itself executed. You could even see that if you filter for success. These are all executed tasks. For the clean build case, let's take a look at that. Now we see, let's see. Yeah, clean had to be executed, of course, because you can't cache a deletion operation. That doesn't make any sense. And as I mentioned earlier, file I/O kind of tasks like jar, no point in caching that. It's actually slower to come from the cache than just to re-execute that. So that one had to be executed as well. And now we can do it again with no build cache turned on. So if you ever want to disable the build cache for some reason on an ad hoc basis, very easy to do that. And here we see it's significantly slower. So all these tasks that were previously came from the cache, in this case, were executed. Yeah, same as the first time.
What is it actually? Is it whatever the task just outputs in our task, or is it something internal?
No, it's caching the actual declared artifacts. So in the case of a compilation task, it's caching the class files or the jar. Oh, no, the class files. The jar task class is the actual jar file. Sorry, it doesn't cache that. You could turn it on, but you shouldn't. Whatever the declared outputs are, it's what it caches. No internal representation. So it's very transparent and straightforward.
And one way to kind of look at this is there's your performance tab. That's kind of your build performance friend, right? There's a settings and suggestions here. Sometimes it'll, like if you're resolving dependencies during configuration time, it'll catch that and it'll give you some recommendations there.
Caching was off for this build,
Yes, caching, oh, okay,
so if you want to look at the other one.
right. Yeah, thanks. Right, so yeah, when your cache is off, right, obviously in your switches, you could see, hey, was my build cache turned on? Yes, it was. And you'd have this build cache tab, right? We didn't have this guy on the last build scan. And you can come there and see, okay, I got 3 cache hits, and it's 100% cache hits, right? And then I usually go to task execution, and you can see, okay, well, these are the 3 that came from the cache, and which Tony has shown already. So let's look at the 2 that weren't cacheable. These 2 folks weren't cacheable. But what's also interesting, I mean, this is a small test project, right? But when you run this at home or with your apps built, you might see some things that were cacheable, but they were executed, right? So that's how these are the 2 things that we monitor to say, hey, how do I get 100% cache hits? Right, and that's what we do with our enterprise product, right, is because we look at, hey, you're gonna turn on this cache, and you might get 30, 40, 50, 60% cache hits, but how do you get to 80, 90% cache hits, right? So you wanna kind of monitor, yeah, Tony, you wanna give a good example for that?
Well, I'm showing again the chess project, because I ran this build earlier today, and I saw that there was a 81% cache hit rate, which is okay, but not great for a build that was on the same commit that had already been run somewhere else. It should have been closer to 95 or even 100%. You can investigate that pretty easily going to this task execution tab, clicking on this link here. So these are executed tasks that were cacheable, which means that they maybe should have come from the cache if in an ideal world. And now I've filtered my view for all of these tasks that were cacheable but had to be executed, and then sort the list by longest, get the most expensive ones first. And I'm not surprised to see that it was the compile debug Kotlin task that was the longest running task. And that's a problem, and I know why it's a problem here. It's because data binding is not yet cacheable in AGP 3.5, but will be in 3.6, I hope. No, yes, this is a 3.5 build, I believe.
Oh, well, let's find
No,
out.
actually it's 3.4.2. So it might be better in 3.5. I haven't tested that lately. Yeah, so this is what it looks like for an Android project, basically, a typical Android project. You see all these compilation tasks, these resource tasks, cap tasks. They're the ones that are causing a lot of problems for devs right now.
And can you go back to the task execution tab? So what's interesting here, there's 7 minutes worth of stuff that was cacheable. So you might think, hey, 80% cache hits is great, right? But if you have like a big deadline and you guys have a big release and there's like 4 or 5 developers, whatever, working on your app, right, your number of builds is gonna go up. Your build time is gonna go up because you're building new things, you just wanna get this release out. And if your build isn't as optimized as it could be, you guys can lose a lot of stuff there. So that there's 7 minutes worth of stuff. I mean, it's running in parallel on 8 cores. Sure, it's not gonna be exact human time, but that could be up to 1 minute of wait. Now, if a 10-person Android team runs 1,000 builds per week, right, you can see how this stuff is gonna add up really fast, right?
Yeah. And what else? Okay, and determine, let's do the last one for completeness. This is which tasks are not cacheable. Okay. Yeah, it's pretty easy. Timeline, look for, I'm not
in here, Tony?
Oh, it's talking to myself. I'm on stage. It's great. Great speaker. So here I am looking at the timeline view, and I'm finding all the tasks in my build that are not cacheable, because they might be a good. If I've convinced my manager to give me time during an iteration to make my builds better, I'm like, well, this is what I want to focus on. The most expensive tasks that aren't cacheable, can they become cacheable? Can I fix that problem and make my team happier? So this is what you could do with a build scan. It's a pretty powerful little tool, build scans. Okay, and someone had a question about network activity. So one thing that build scans show is all network activity. In this case, there was no activity. But if you're seeing a lot of stuff happening here, like a lot of things getting downloaded, that kind of suggests you might have dynamic dependencies. When you use the little plus notation in your dependencies block, it tells Gradle that you want to use that version or anything higher than that, which might be valid in some cases, but it also means that Gradle will once a day reach out to the network looking for newer dependencies, and that can slow your builds down. So everything comes with a cost. The default is once a day. If you use dynamic dependencies, by default, once a day, it'll look for new ones. That's configurable, though. Well, if it's on CI, that's a good point. If it's on CI and you're using an ephemeral agent, there's no cache. There's no local Gradle cache. I'm not saying, I don't mean build cache here, but like dependencies cache. Then it'll check every single time. And it has to download it anyway because it's a new agent every time. So those things are very slow.
Do you want to show a quick build diff example to debug a cache miss?
I did show that kind of earlier, but it gets really complex really fast.
So one of the reasons why we created Gradle Enterprise is once your number of builds becomes really high, how do you get to that 80–90% cache hits, right? So, we do this cacheability test where you run a clean. Oh, you want to talk about cacheability tests? I mean, you kind of invented it.
That's true. If the best way I've found to optimize caching for a build is, the first thing you should do is run 2 builds in a row. Gradle, assemble, debug, Gradle double assemble, debug. So that's a no-op build, no clean in the middle. If anything at all happens in the second build, there's a problem with your incremental build, which is a huge problem. So once you solve that issue, which is probably Crashlytics, the next thing is to do Gradle clean build, or assemble, debug. And now, because there's 2 builds in the same workspace, everything should be pretty identical, and if it's not, you got a problem. You can solve those issues. Again, it really helps to have build scans for this. So that's the first experiment, I call it. The next one is check out your project in 2 different locations on the same hard drive. So it's the same environment, but different paths to your task inputs. And now you do the same thing, clean build, at both locations. Compare the 2 builds, see what the issues are there. There's going to be something probably with absolute path normalization. And then the third and final variant of this experiment is to have a CI build and a local build, and then compare those 2. And that shows you environmental issues. So I did demonstrate that, I think, very quickly early on. I'll show it again. So yes, the 2 builds, Jenkins and local. I can compare them.
And basically what Tony is doing is, hey, why wasn't all this stuff cacheable if I just ran everything and put it in my local cache, right? And so now,
yeah, I mean, as devs, we talk about having dry code. Don't repeat yourself in code. We want to have dry builds as well. If you're building something twice in 2 different places in the world, to me that's waste. So if your colleague built it or Jenkins built it somewhere, and you have the exact same thing, and you have to build it again, then you wasted CPU cycles, and you shouldn't be doing that. So here I have a Jenkins build on the left, my local build on the right. First of all, you can see the infrastructure tab. Jenkins has 48 cores, 12 workers. My local Mac has 8 cores, 8 workers. See all these differences already. That can lead to issues. Or maybe not, depending on how your build is structured. So do you see the JDK involved here? This is like really, really helpful in some very esoteric cases. The switches that are different. I can see custom values that are different. This is one reason why custom values are so useful, because they show up in the build comparison view. I can see, for example, if one build was dirty, one wasn't dirty, the local changes on one, not on the other. The branches can be different, that kind of a thing. And I'll skip this one because it's really weird. But then this is so if I want to look at compilation tasks, compile debug, I think, Kotlin, yeah. So this is the most expensive task in the build. How to be executed, that's really, really annoying. Nothing had changed. I can see that it's the compile Kotlin task. And when I start digging into it, looking at the actual files that are input to this task, I see that it's going to be, it's data binding related. So data binding is not cacheable right now. I think it is in 3.5 or 3.6. I see someone's nodding their head. So very soon this should be a solved problem, but for now it's an issue. And so I can't do anything about it in this case, unfortunately. But in other cases I can. So to give you an example, one of our customers is SoundCloud, and they use AIDL. And so they noticed that the AIDL task was not coming from the cache. They didn't understand why. They used this very feature I'm showing you right now. They looked at the file in question. So as you can see here, it points to the exact file on disk that has the issue. You can cat the file, open it in your IDE, see what's going on there. And they did that, and they saw that, oh my God, the Java file that the AIDL generated looks fine, but the tool output a comment with the absolute path to the source file in the source code. And so obviously it's going to be different on different computers. And it's like, Google, I mean, come on, give me a break. Don't tell them I'm saying this. I
mean, it is recorded, but.
it's okay. This is all public source stuff, so that's not an issue. This is let me see, where is it? It's going to be a white list. So Google has all, this is open source, so this is not like a dirty secret or anything, but Google has all these caching problems in AGP that they've whitelisted. So you can see the list right here. It's pretty funny. They're working on it. We're working on it with them. But this is the kind of thing you deal with when you work at Gradle, is solving these kind of problems with your friendly Google devs. Anyhow. So.
And the point is sometimes you just need more tooling to solve some of these super complex problems, but you know, the impact is going to be huge, right?
Yeah, and the point about the AIDL story was that even though it was a task that the SoundCloud didn't own, they were able to work around it by basically adding another task action to that AIDL task. They just rewrote the file on the fly, stripping out the comment, and that saved them like 30 seconds on each build. So there's things that you can do once you have visibility into what the actual problem really is.
And by the way, 30 seconds on each build for that team saved them 2 full-time developers in 1 year, like just engineering hours as a whole, right? So you'd be surprised how many builds your Android developers are running.
Yep. Good.
Let's do the remote cache.
Okay, so I've discussed this at length, I think. The way caching works in general is, the way Gradle builds is when it's going to execute a task like compile, debug, Kotlin, it first checks to see, has this already been executed on this machine today? Is it already in the cache? Or by that I mean like the Gradle, not the build cache, but like its memory cache. And it says, oh yeah, this task is up to date. It's just done. I'm done. I'm done working. It's good enough. If it's not up to date, the next thing it does is it checks the local cache for that output. If it's there, that's great. It's done at that point. If it's not in local cache, it then takes the remote cache. And if it's there, that's great. It'll actually take it from the remote cache, put it into the local cache, so the next time it's even faster. And if it's not there, finally we'll execute the task. And all this happens very fast, under a second in most cases. Much under a second, like milliseconds we're talking about. So this lets us share task outputs across an entire team and CI infrastructure. And that leads us to lab 4, remote cache.
What's up with this LinkedIn password?
I have no idea. Ignore that. Well, no, maybe don't ignore that. Oh, we did a workshop at LinkedIn.
Yeah.
It should be Gradle still, I think.
And so how we use the remote cache is, and we just have CI cranking all the time. We have developers all over the world. So we have multiple cache nodes. We'll talk about that. And CI writes is pushing to this remote cache node. And so that first build of the day, that's usually the longest, right? Now everything is, so most of the things are built already by CI. So you just fetch from this remote cache server, and then it populates your local cache. That's the super cool thing about it, right? So every consecutive build is now tapping into this local cache, right? So you see these, so that's just for local builds. And of course, as Tony mentioned, you know, you make your CI builds faster. Hey, don't rerun tests that are up to date, right? So a lot of folks are running CI builds all the time. And, you know, we have some customers that run CI builds in the cloud, right, on EC2 or something, right, or AWS, whatever you want to call it, right? And by reducing those build times by 20, 30, you know, percent is a huge impact as far as money saver goes.
It is LinkedIn, I think.
Okay.
Let's double check. I just checked it with Gradle, and where did it go? There we go. Is it all lowercase?
Yeah.
Yeah, okay. Let's try that again. Yes, it is LinkedIn. Isn't that funny? It's not the real builds though, so it's fine. Okay, just double checking that. Yeah, and Ruz mentioned briefly that there's only a single node here. I think it's even in the README. Yeah, only a single centralized build cache node. But it's, if you have a distributed team like we do, we have developers literally all over the world: Europe, Australia, Hong Kong, US, Canada, South America, pretty much everywhere. And so we actually have 3 different remote cache nodes. One in Frankfurt, Germany, one in San Francisco, and one in Brisbane, I think, Australia.
Yeah.
And Gradle Enterprise handles replication of artifacts across that whole node network. And what you need to have is the node to be as close to your devs as possible, because obviously it's like speed of light is a limiting factor. We can't go any faster than that. So the shorter the wire, the better you are.
And so to use the remote cache, you have to set up your own cache backend, or you can buy ours that ships with Gradle Enterprise.
Yeah, once again, like that's a free service. You can just download that. And here we specify, this is where the cache lives. In this case, it's attached to the Gradle Enterprise instance. Yours might be somewhere else. Just give it a few minutes while people work through the lab. Yeah, so I'm doing that, okay. Just one more, I think.
I think we have the visualization. We probably only have 10 for one.
There's an export API lab. It just shows builds coming in real time.
I guess you might as well. Is that really a lab though? Or it's more like a neat demo?
Yeah. When you're on this this part of the lab, consider working with one of your people next to you and make it the same exact change. And then you might see that your task will come from the cache that they push to. So that's pretty cool. You can see it in action. Oh, it's right there actually. Okay. Yeah, cool. Is anyone still working on this? Cool, I'll run through it. So I already ran some builds. Let me just put this next to it. Yep, already ran some builds. So let's go to the test task and the timeline view. And it came from the cache. Yep, okay, that worked.
So can you explain more what that's doing there, Tony?
Right, as you know, as I've mentioned before, with compilation tasks, the thing that's cached is the class files. With a test task, what's cached is actually the test reports. So tests are often one of the most expensive parts of a build. They're very computation intensive, but if the inputs to the test haven't changed because the actual source code hasn't changed, so the reports ought to be the same. So we cache the reports, whether it's an XML report or whatever, and then that's just what we pull from the cache, is those reports. And why is it doing this to me? By the way, I hit Max to rearrange all my stuff all the time. Okay. Oh, okay. So there's a little button right here that goes to the origin scan. So this one ran actually quite a few days ago, almost a week ago. So this gives you some like a sort of a chain of what's the word? No, like an auditing chain. You know where the output came from. That all worked. Did anyone not get cache hits on that first build? Cool. And then let's make a change to the example. So does someone want to tell me what change they made so I can make the same change? Oh, underscore? Sure. Cool. Thanks. Oh, the test fails, of course, because it's, yeah, that makes sense. The test verifies that there's a space, not an underscore, which demonstrates that the test caching works. It didn't cache that. Let's see, compile Java would be the task. Oh, it didn't come from the cache, interesting. If I run it again, oh, wrong thing. Why didn't that come from the cache? So you're for remote cache clean. Am I in the right lab? Yeah, I am. Okay. That time it did. Interesting. So compile. I don't have that, unfortunately. What would have been nice is if we actually used that custom values, we're adding the get status to the build, we'd see what the actual changes were. So that should have came from the cache, but it didn't. I'm surprised.
Yeah, exactly.
Live demos, right?
Yeah, there you go.
What was that? Oh, you changed the test file? Oh, that's why. Got it. Got it. I read too fast. Thank you. So what did you change here? One, three, four. So like this, and then yeah. Okay. I shouldn't even need to clean it. Actually, it should just come from the cache anyway. Looks like it executed. Well, I don't want to belabor the point. Compile test Java. Must be a slight difference. Could be a spacing issue, because actually it's not obvious, but this matters. That all matters. Space here might matter. It gets pretty. It's very complex to make those things not matter, and so in the we err towards simplicity for maintainability purposes with our sort of analysis of the code. Yeah, that's why. Yeah. So now we've learned something. Where are we? Are there any questions on Lab 4?
On the operating system.
No. The OS ought to not matter. So the question is, does the operating system matter for the caching? Yeah, and the answer is generally no. But it can be yes. So let me show you an example of that. So if you look under infrastructure, you'll see that one of the things here is default char set, UTF-8. if you're on a Windows machine, it's probably going to be something very different. If you're in Russia, it might be something very different, or China. And so if the charge set is different, then you might have weird things with your tests, because the string interpretation matters, you know. So yes, OS can be an influence, and you can see that very clearly in this infrastructure tab. But generally it's no. Yes, so that's a good question. So it's are there any timeouts for the remote cache? And the longer answer, the quick answer is yes. The longer answer is that if the build cache fails, if publishing a scan fails, your build will not fail. It just means you'll get a warning in the console output, or the build cache might say, couldn't reach the cache, sorry, gonna have to execute the task. And you can see that for yourself very easily if you just change the credentials in the settings.gradle file. You'll see a 401 unauthorized, like I saw when I had the wrong password in, and it just executed the task instead of using the cache. Are there any other questions? Okay, we're running short on time. Is that where I wanted to be? No. There we go. Okay. I still can't do it.
This is not,
Yeah.
I don't even know what this slide is.
Data is essential. Okay, so this is a good slide. We often get the question, okay, so I did a trial with Gradle Enterprise, I made my builds faster, why should I now buy your product? That happens all the time. And the answer is that if you don't have to, but it's a guarantee that give it a week, give it a month, give it a quarter, you're gonna hire someone new on your team, they'll do something dumb, they'll break your build somehow, and then you'll have no visibility into that whatsoever. These regressions are a real thing, they happen all the time. And Ruz was will tell the story about Spotify. They double their code base every year.
Yeah, so certain customers we work with, their code base increases by 100% a year. Gradle Core increases by 33% a year, right? So you see a lot of build time regression. So it's not a, hey, I'm gonna fix my build time once. This is a one and done kind of a thing. You have to constantly look at it and try to find build time regressions and basically have an actionable way to act on it, right? And you can use build scans for that as well, right? So it's, hey, what you want to find these tasks that run the most, that run the longest, that developers are facing every day, and cache those. I remember one of our customers, they're like, hey, there's this React Native task that every developer is running in every build, and this thing is taking around 30 to 45 seconds, and nothing has changed in it in the last month. Mm-hmm. Can we cache this thing, right? And so by finding certain things like this, and you can kind of, because things like this will get introduced into your build on a regular basis, right, as you're trying to innovate and get more features out the door.
Yep. Yeah, so what happens today is that you just don't notice it. It's slowly eating away at your performance and your happiness, and you just have no idea until a year later, builds are taking twice as long and you don't know why. So it's very important to monitor these things.
And you can monitor them yourself by capturing the data for all builds. Mm-hmm. Or you can use kind of our tools, right? We've seen, folks do it with spreadsheets or whatnot, right? It's, so there's, at the end of the day, you want to look at the data. How you want to look at the data is up to you. So, Tony, you want to show how we look at that data, how we find build time regressions?
Yeah.
You want to show the chess example?
What was the example?
Just let's show the build performance dashboard.
Oh, yeah. Sorry. So again, this is an Android team, chess.com. There's a neat view. This is the build trends view. Let me give it a larger time span. So it lasts 4 weeks, let's say. So what's funny here is you can see the weekends a little bit when builds go to 0. But yeah, so in the past month, this team, 4,000 builds. They spent 4 days building their app in the past month. You see how many builds there are per day. You see amount of time spent per day building this thing. You can really easily see the build data here. So this is build time changing by quite a lot over this time span. I think this may have been a weekend or something, so there was very little data involved, so one slow build makes the whole thing look really weird. You can actually normalize that to just a week data count. Yeah, but this is more interesting. So yeah, you can use this, we're a data platform. You can see how your builds are performing over time. You can look for regressions, because humans are great at pattern recognition. You can easily see these weird patterns, and you can investigate what may have caused this kind of issue and then solve it.
Can you can we see local builds?
Sure.
Specific?
I'm actually gonna
How many developers work on this team, Tony? Can we
Like-
share that?
it's like 6 developers right now.
So 6 developers within
It's like 3 months.
within
5, 6,
3
7,
months
4
are
months.
doing 16,000 builds, right? And the cumulative wait time is interesting, right? So the average build time for these is 40 seconds. So these folks, they've waited 7 days worth, these 6 developers, 7 days worth, and their builds are fairly fast, right? And if this thing doubles, you could see how that's gonna affect the cumulative wait time.
Yeah.
And it's not like you could go do something with a 40-second build. What are you gonna do? You can't even go to the bathroom, right? You might be able to, check Slack or maybe do
Yeah.
one Slack message, maybe.
Right, exactly. So for a bit of context here, this team, 140,000 lines of Kotlin code across 60 modules. So that's about the size of the app right now. So they kept it pretty fast. There was a time when it was going up, and they noticed that, and they brought it back down again just by active monitoring. I think a 40-second build is not bad on average. One line of code change can be much faster than that.
Could you click on the performance? And so I remember, I've been at Gradle for 6 years, and we had a customer that said, hey, when build times get above 5 minutes or 10 minutes, I forgot what he said, but he's like, I want to get an alert. And we're like, okay, well, what's that going to do? So this is kind of where that came from was, okay, well, instead of an alert, how about with a few clicks, I could say, show me all the local builds, and I could see the trend. Hey, is it one build that is going up, or is it a series of builds? And then get the context, but also be able to take action and click on one of these. And of course, like I said, this is something that we sell. You can capture your own build times in your own different ways, right? And the remote cache here is,
It's not very,
okay, can you do a CI?
no, don't know.
Oh, okay. You want to do CI for us? I just wanted to demonstrate
Oh, yeah.
the savings of local builds, remote cache on CI. So with some of these labs, right, we had to make them super fast, right, and they can't be like 3-4 minute builds. But so this is Gradle Core. Actually, can you do Gradle Core?
Oh, yeah.
So many folks today are running CI builds without any caching, right? And you look at it for us, right? Average build time, average CI build time is 2 minutes. This is this guy right here. It's around 2 minutes, 34 seconds. And we're saving around 15 minutes per build. So if we didn't do, all the gray stuff is basically how much we're saving on our CI builds. Our average CI build time would have been, the 2 minutes plus the 15, around 17 and a half minutes, right? The impact of that is huge, right? Especially if you're waiting on PR builds to finish, so.
Yeah. You can even see it here, like, if you hover your mouse over this, in the past week, Gradle Core spent 17 days building. So 17 days over 7 days is quite a lot of building. Hover over the avoidance savings, 104 days not building, right? So that's cut our CI infrastructure costs by an order of magnitude.
Yeah, and that's, 25 developers work on that team, right? They're at this conference, there are some Android teams that are, 30, 40, 50 plus.
Yeah. So it adds up pretty fast.
Question?
The question is about cache hits with remote cache. It's the same for a local cache. We just, it's essentially a key value store. So when you have those inputs to the task and then you check for that string against the local cache and then the remote cache, if it gets a hit, it pulls the value out of the cache and it just serves it up to you. As far as the credentials go, Yeah, they have to be correct or it's not going to work, but that's really all that comes into play there. Does that answer your question?
We have 5 minutes.
So we talked about debugs in general, like so examples of debugs. How the remote caching and remote caching generally works, remote caching specifically works with the release versions that, let's say, does it get, say, like, program runs every time of the release, right? Do you guys cache that card and then you like some of it to the point where the card release and the release still happening? Just to figure out, say, do you guys cache it so that you're able to run it, if you're moving faster in that case? My biggest issue when I work with Gradle is that whenever I switch from debug to release, you know, like, it just takes like a lot of time, and I always wonder,
The question's about, in an Android context, switching variants from like debug to release, and how does the cache play with that? Yeah. I have to say, it's technically possible for ProGuard to be cacheable, but it's not in Android right now. You have to do some custom wiring for it to work. So ProGuard actually is bundled with AGP. In vanilla Java, it's like a separate thing you have to do deliberately. In AGP, you still have to opt into it, but it's bundled as part of the tool. So it's harder to manipulate it. So it's actually not really feasible to cache your ProGuarded APK, basically, in Android. And it also doesn't really matter in the end, because when you're building a release APK, it's almost guaranteed you change something. And because the release APK is the leafmost thing that happens, something will have changed. And so you really just can't cache that APK generation. It's going to have to be executed every time. I'd like to see that if you're using D8 and R8, they're faster at least. They're like several percent faster than ProGuard, and they'll probably get faster as time goes on. But as far as caching, they can't be cached really, and it also doesn't make a whole lot of sense, simply because something has changed. And if any input changes, then the thing has to be re-executed, if that makes sense. The comment that I see that impacts this context is if your build config, if you're injecting like a git hash or a version number in your build config, that's going to hurt you a lot. If that build config.java file is changing, then they have to recompile basically the entire app module every time that changes. So if you're using a git hash, if it's a version number, if it's your username or something, that's one of your build config variables. You really shouldn't do that. And I can talk about it more after the talk. Just come up to me, we can discuss it. But it's a real big problem. You just try to avoid doing that. There are ways to make it faster, but they're not typically cache related. And I'm happy to talk about that after this workshop. Yeah. Yeah. I have a whole talk on that, but we got 1 minute left.
You want to speed through the rest? Okay. Well, you all have the slides and the labs if you want to continue, so we kind of have to kind of wrap this up here. Yeah, there's a failures dashboard, flaky tests. There's some cool stuff on here. We already showed the build diff. So we have a booth here. If you want to trial Gradle Enterprise, there's a Gradle Enterprise trial 30-day evaluation. Feel free to come and talk to us about it. Tony and I will be at the booth till the end today. So if you want to run a build scan and bring it over to us and say, hey, why isn't this thing cacheable? Or bring 2 or 3 build scans, sure, bring it over. We'd be happy to look at it and give you guys some advice. And yeah, so thanks for coming and
Thank you.